Okay, so as a follow-on to the previous video, I am going to be demonstrating how to create what is known as a rainbow hologram. Others might also refer to it as a Benton hologram. So there are two key differences between what I showed in the previous video and what I'm going to show in this video as in terms of how we create this type of hologram. The first difference is that we illuminate the H1 plate with a slit. And as you can see here, this can be achieved by using a cylindrical lens. The other difference is that we illuminate the H2 plate with the reference beam from the same side as the object beam. So this would be typical of a transmission hologram. In other words, what was created in the previous video was a white light reflection hologram. Now, what you are looking at here is the cylindrical lens, and as I move it into the path of the beam, you can see that it projects this slit onto the H1 plate. And I can also move it at various distances to achieve either a more or less narrow slit onto the H1 plate. Now, the advantage to using a cylindrical lens over just an ordinary mask is that a mask would waste a lot of light. So by using a cylindrical lens, we can preserve a lot of the light and be a lot more efficient with it. And here you can see the image projected onto the index card, and it looks a lot sharper compared to what we saw in the previous video. So I am optimistic about the result that will follow. So here is the resulting hologram, and I have to say this is not quite what I expected. As you can see, the reconstruction, the replay of the hologram, it just shows a very narrow region being illuminated at any given time. And you might think that that's because of the slit, but a actual rainbow hologram should show a lot wider viewing area at any given time. And I came to find out that, well, the slit orientation was actually incorrect. In fact, it is supposed to be oriented horizontally with respect to the original hologram orientation. So even though I had it horizontally on the table, because I had rotated the H1 plate 90 degrees on its side, the slit therefore also has to be vertical. So now that I've done that, I now have a vertical slit. I'm going to create the second attempt hologram, and then we can see what that looks like. Now, before I share the final result, I did want to point out two things here. One is that as I illuminate the H1 plate, the master hologram plate, with the slit, this is a much wider slit than I actually use, but I do this so that you can see the pseudoscopic image of the H1 hologram. And so I just thought this was interesting because you can actually, depending on the viewing angle, you can actually see different parts of the object, so you can actually make out different text shown through this slit. So I thought that was interesting. And the other thing I wanted to point out is, again, the reference beam is coming in from the same side of the plate as the object beam. So again, this is representative of what might ordinarily be a transmission hologram. So again, just to reinforce the notion that the reference beam is coming in from this side. So unlike what I showed in the previous video where a reference beam comes in from the opposite side, here for a rainbow hologram it comes in from the same side as the projected image. So this is the final result, and as you can see, it is much more colorful and vibrant than that first attempt. So what I like about this is that the image, it looks very clear and sharp, and this is even without using a cell phone flashlight to illuminate it. In fact, I'm just using the ambient lighting from the ceiling lights. So this is actually pretty nice to have this well illuminated. In fact, you wouldn't even really be able to use the cell phone flashlight unless you had it angled from the opposite side. In other words, coming from the same angle as the ceiling light. So anyway, I'm pretty happy with this as a starting point. So thank you for watching, and see you next time.